Hi, it's Mr. Baker here. Today we're going to be doing an experiment on refraction using a brilliant simulator from the University of Colorado called PhET. So when you first go to the PhET website to do with refraction, this is what you'll see, and you'll need to click on the intro to bending light when you go on this. Okay, and this is what you'll see. So what we've got here then, we've got like a laser that I can move around. I can change the angle of my laser. I can turn it off as well. I have got the different material up here above the line, so I can change this material here. I can have air, or I can have a different sort of custom thing, or I can change it to water or glass or anything I want, and I can do the same thing down the bottom. So at the moment it's air at the top and it's water at the bottom. Okay, and the one we're going to be looking at is using this protractor here. So we can put the protractor on there and we can measure the angles that we're looking at. Okay, let's first of all look at what refraction actually is though, and the best way to do that is to look at it as if it's a wave. So if we had our light ray on like that, so that's a ray of light like a laser beam or something like that, if we were to zoom in on that and look at it like this, then we might be able to see where the sort of the peaks and the troughs, if you can remember to how light is a series of peaks and troughs of light, this transverse light that's coming from our laser beam. So say the dark bits might be a trough and the red bits might be a peak, and it's going along like that. And you can see what's happening is that the light's coming out through the air, and you can see that these peaks, so the distance between one red and the next red is longer than when it's here. So the wavelength here is longer than the wavelength here. And refraction is all to do with the changing in direction of light as it goes from one material to another material. And it does that because through air or through a vacuum, the light can travel slightly faster than if it's going through material like water or glass or diamond or some other material like that. And when it does that, at the boundary where the light actually hits, you can see this difference here very slightly. You can see that on this edge the light carries on travelling fast, but on this side it's got to suddenly go slower, and so because of that it bends, it changes direction, and that is what refraction's about. And so the difference between the materials you have, if you've got a large difference between what they're made of, then you're going to have a larger refraction than if you've got a smaller difference. And so that's what refraction is, and I'm going to just quickly show you how to do the experiment, and then maybe you can have a go at that as well. So what you'll need to do, like I did before, is you'll need to drag your big protractor up to there onto the line. So this dotted line, if you can remember, is called our normal line. It's at 90 degrees to the surface, and when I switch that on, you can see that some of the light is going through and being transmitted through, and some of the light is being reflected. We're not particularly interested in the reflected light right now, although very quickly we could just do the experiment here, couldn't we? So if we measure the angle from here, that's 60 degrees. Our angle of incidence is 60. Look at our angle of reflection. It's the same, it's 60. And that's something that you've probably done before when looking at reflection. If this one's 30, our angle of incidence is 30, our angle of reflection is 30 as well. So you could do that experiment looking at reflection and looking at the light that comes off and doesn't go through. What we're mostly interested in today though is this light that's going in and is being transmitted through and changing direction because of the difference between this material and this material. So what you're going to do is you're going to take your laser, and the first thing you can do is put it to 0, and you can see that when the angle of incidence is 0, the angle here that we're measuring here is also 0. Okay, so you would jot that down in your table, and probably the easiest one if we go to 10 degrees each time. So this angle here is 10, and then you'd measure off down here, and I think that's about 7 degrees. So our angle here, and you remember you always measure it from the normal to the angle of incidence, is 10 degrees. So our angle of incidence is 10. Our angle of refraction is 7 degrees. And you jot that down in your table as well. Then you would carry on doing this. You would put that at 20. So our angle of incidence is 20, and we would measure what that angle is there. We'd go to 30, and so our angle of incidence is 30. Angle of refraction, you'd measure that off, and you'd keep on going round until you go there. And then hopefully you'll be able to make some kind of conclusion about what happens to the angle of incidence and the angle of refraction. And then if you have done that, then what you can also do is you can change what you're using as your material that is the light is being transmitted through. So you could change that to glass there, and then if you change that to glass, you can do the same experiment and see what difference it makes when you've got a different material like glass instead of water as the material you're transmitting through. Okay, so that the main things to remember is that refraction is to do with the change in direction of a wave, or light in this case, as it goes through one material to a different material. Okay, that's it for now. I've been Mr. Baker. Thanks very much. I'll see you next time.